Hello, today we are going to share a question on constraints of graph. All right, so it's a common question, and a lot of students, after a couple of years of studying, right, we are pretty much have pretty much forgotten about all these different kinds of graph, and they are, in fact, really, to be honest, they are not easy to memorize, right? All these different types are so different from one another, right? So first, let's go to the x square graph. Like for x square graph, it's either a smile or a frown, okay? That's the only two. And then if you have a negative coefficient, it will basically decide the shape, right? -3 means that it's going to be a frown. Okay, so the negative will decide there's a frown. If it's a positive number, then it's going to be a smile. So another thing you got to take note is that you also need to be very clear with the y-intercept. Now, in this question, there is no x and there is no c, meaning that in this case, it's 0 and 0, right? The c is basically your y-intercept. Now, if there is no constant number there, this means that if it cuts the y-axis, it's going to be at the origin, all right? So you draw the x and y-axis, draw it pretty high up because you know that it's going to be a frown. Starting from the origin, goes a ways down. Label the name of the equation, and that's it. Will be done for A. Now for B, this is a negative linear graph. For a linear graph that has y equals to mx plus c format, it is either a sloping outwards graph or a sloping downwards graph, right? So the number that you have to take note of is the m. This m will determine if it's whether it's sloping upwards or sloping downwards. So right now the 5 is currently showing a negative number, which means that when you go from left to right, it should be sloping downwards. So you're going to choose the second direction here. And also at the same time, this constant number is still representing the same thing in the quadratic equation. The letter C here represents the place that you will cut the y-axis. So it means that you will cut at -1. This means that when your y is on the y-axis, right, when the x is 0, your y is -1. And because it's sloped downwards, we just need to make sure that this line cuts through the -1. That is your answer. All right, question C here is equation on having x squared in the denominator. Now for EMATH, typically they will just give you up to x squared, right? But sometimes they might be take it up a notch and give you something like maybe instead of giving you x power of 2, they might make it becomes a bigger multiple of 2, such as every other even number that you see, okay? So why am I showing you these things is because for all of the x that has an even number, there's even power, their graph is all going to look the same. The only difference is the steepness of the slope, okay? So just remember that for x squared graph in the denominator, it's going to look like a slide. It's going to look like a tree trunk on both sides, okay? And make sure that you do not touch any of the axis. You can never reach the axis because when your x is 0, even if you put a square over there, it's going to cause the outcome to have a math error. And since x can never be 0, your y can also never be 0. So this x and y axis becomes the two untouchable areas, okay? And of course, if let's say the question gives you like a negative coefficient for the overall, if they put a negative sign here, then this will mean that you will be flipping everything like underneath the ground, right? Because all the values of y is now going to turn negative. But currently there's no negative sign, so this is our answer, ready? Right, the next one for question D, this is on y equals to -5 to the power of x. Now, first of all, let's study the basic exponential graph. That means when your x is in the power, the basic shape is going to look like this, okay? Like an aeroplane trying to take off. So once again, there is no values for x, right? No matter what you put in, it will never result in y being able to become 0, right? You can try it. You can try -10,000 all the way to positive 100,000 for x. The y will never be equal to 0. So this y-axis becomes a region in which that you can never reach. Yeah, and of course, remember for the basic, without any constant there, without any like number there, right? There's no +3 or whatsoever. By default, on the y-intercept, it should be cutting at y is equals to 1. Now, reason why is that y is equals to 1 is because when you have x equals to 0, that is for y-intercept, right? When x is 0, y, 5 to the power of 0 is 1, okay? However, take note that there is a negative sign attached to it. So once again, if the negative is attached to the overall outcome, that means attached to everything, okay, it's going to reflect it like along the x-axis underneath the ground. So everything is going to be inverted, including the y-intercept, because -1 is what you get, right, when the x is 0. And it's going to slope this way downwards. Okay. Take note that for the sketch of graph, you should always indicate the y-intercept if there is a possible. But of course, like in question C, you can't really indicate any intercept, right? All right, question E. Now again, for EMAF, they will typically only test you up to the power of 1. But for more complicated questions, especially if you take AMAF, it will go up to a power of 3, a power of 5, so long that it's an odd number, it's an odd power inside the denominator. Then your graph, typically without the negative sign, your graph is going to look like this. Okay. Reason because with the odd powers, let me remove the negative sign first. So this is an example. If your overall is just a positive outcome, then the answer for y is going to be in the same region as x, which means that when your x is positive, your y will also be positive. But when x is negative, if you cube a negative number, the end result is still negative, which is why both of them are underneath over here. Okay, this is for if you have an unknown x in the denominator that has odd powers. Okay, but likewise here, just like your question D, they did put a negative sign attached to the overall, right? What is going to happen is if they put a negative sign, it's going to reverse the y values from negative to positive. So what you need to do is to reflect along the x-axis, which means that it is no longer found in the first and third quadrant. Okay, if you learn your AMAF, we call this quadrants, right? So if you do a negative sign, it's going to now go into the third quadrant, will now reflect above the x-axis. It's going to be in your second quadrant, and the first quadrant here is going to reflect underneath to be in the fourth quadrant. Okay, so it's going to look like that, like sort of like some kind of I don't know how to call it, like some kind of sound wave trying to bump into each other, right? All right, but take note that in this question here, there is not just a negative. It makes the thing more complicated because there is an additional of a +2, which means that you need to basically lift the whole thing up by 2 units. Okay, so in this question, there is actually an x-intercept. Okay, so which means that you will probably let it cut above here. All right, and then this one you also leave it higher up. Let me do it again. Okay, something like that. And if you want to find out the x-axis, this question didn't say that you have to, but it's always best to do a good practice since that's the only intercept, right? We are going to sub in x is equals to, no, in this case, even if you +2, I'm sorry, it will still not be able to lift it up because x can never be 0, right? I'm sorry, what am I talking about? Okay, when you want to find the x-intercept, it should be something y equals to 0. I also still get confused from time to time. When you sub y equals to 0, that's where you can find x, right? So you're going to have -4 over x plus 2 is 0. -4 over x is -2. and -4 is -2x, so x is 2. That means it's going to cut at 2. Okay. All right. Now, lastly, for f, that is a cubic graph. So cubic graph is going to look like an S spine, right? So it's going to face this way like that, which means that it will start to speed up to slow down in the middle like a chair. It's like a chair, and then after that, it's slow up again, right? So this is like a very comfortable chair looking. And of course, if let's say you have a negative coefficient of an x squared, then the whole thing will basically flip upside down like this, right? Face downwards this way, right? So there's no negative sign here. We're just going to draw the basic shape. And again, there is no constant number as well, which means that when x is 0, y should also be 0. Okay, so this is your answer. All right, thanks for the lesson today. We will share the next one, the second question on functions of graph in the next video.